So we're going to see the chemical properties of alkanes. Now, alkanes, they lack affinity. Lack affinity means that they're not going to react easily. And because of this, we used to call them paraffin. And alkanes, they are unreactive. They lack affinity because of the strong CC and CH bonds that there are in alkanes. These bonds have very high bond energy, which means that you need to supply a very large amount of energy to break these bonds. And there's two ways that we supply this large amount of energy. First is by heating. So this is what is going to lead to burning of alkanes. That is combustion. And the second way is by giving UV light. So this is going to cause the CH bonds to be broken. So UV light will cause the CH bonds to be broken, and burning is going to cause both CC and CH bonds to be broken. So alkanes will not react with a lot of things. They will not react with acids or bases or with metals or in anything. They will just undergo combustion. Combustion is 1, and they will go substitution, which is 2. So there's just 2 reactions that alkanes undergo. So we'll see combustion first. Now, there's actually 2 types of combustion. There is complete combustion and incomplete combustion. During complete combustion, there is a plentiful supply of oxygen, which is given to the alkane. And during complete combustion, there is carbon dioxide and water vapor, which is produced as the products. So that's the only 2 products from complete combustion. Now, if there is incomplete combustion, means there is a limited supply of oxygen, which means that you don't supply enough oxygen to break all the bonds, which means that the carbon in the alkane will not react with enough oxygen. So limited supply of oxygen will cause incomplete combustion, and this can produce carbon monoxide or carbon, that is also known as soot, and water vapor. So there's 2 possible products. Either you get carbon monoxide and water vapor, or you get carbon and water vapor. Okay, so that's a summary actually of combustion of alkanes. I'll show you a video that explains combustion in more details.
Combustion is burning, usually in air which is all around us, or oxygen. It's an exothermic reaction, which means it gives out heat. A fuel stores potential energy that can be released as heat when we burn the fuel. An example of a fuel is natural gas or methane. This is the fuel we burn to heat up our food. Methane, like other hydrocarbon fuels such as petrol, can undergo either complete or incomplete combustion. When methane undergoes complete combustion, that is in a plentiful supply of air, it produces carbon dioxide and water, as shown by the equation CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O gas. When methane undergoes incomplete combustion, that's in a limited supply of air, it produces either carbon monoxide and water or carbon and water, as shown by the equations 2CH4 gas plus 3O2 gas gives 2CO gas plus 4H2O gas.
So this is one possible set of products for incomplete combustion. So carbon monoxide and water. Well, the water actually is going to be in the gaseous state. So you can see the state symbols. It says gas there. So it's water vapor actually because of the large amount of heat that is generated. So it's going to automatically turn water to gaseous state.
CH4 gas plus O2 gas gives C solid plus 2H2O gas. Now the effects of the products of combustion. Water vapour, as we all know, is harmless. Carbon dioxide is a greenhouse gas and contributes to global warming. Carbon monoxide, however, is toxic. It's colourless, odourless, tasteless, and so is called the silent killer. Carbon monoxide is often produced by faulty gas appliances. That's why it's important to have your gas fires and boilers regularly serviced. Unburnt carbon is a particulate and is a pollutant in the air. So, to recap, combustion is burning, usually in air or oxygen. Complete combustion of hydrocarbons produces carbon dioxide and water. Incomplete combustion produces either carbon monoxide and water or carbon and water. And the products of combustion have various effects.
So you are now going to complete all these equations. So just you have to be careful. So when there is a reaction which is about complete combustion, you will see excess of oxygen. So that shows that there is complete combustion. So you know the products will be carbon dioxide and water vapor. And if it is incomplete combustion, you will see limited amount of oxygen, and generally for incomplete combustion the question will give you what's the product, so carbon monoxide and water or carbon and water vapor. So you will know what's the product depending on the question. Okay, so make sure you answer these questions. Now let's see the second reaction undergone by alkanes, which is substitution. Now, alkanes do not react with most chemicals, but they undergo substitution reaction with chlorine in the presence of UV light or diffused light or just light. So these are the terms that can be used in the exams paper. Okay. So substitution, what's substitution? Substitute means that you're going to take something and replace it with something else. Okay, so you see UV light is going to act as a catalyst for the reaction. Without UV light, there is no reaction that's going to take place. And this is an example of a photochemical reaction. So photo means light. So this reaction requires light to take place. And substitution involves replacing a hydrogen atom in an alkane by another atom. So in this case, we are replacing hydrogen by a halogen atom, that is a group 7 element. Okay, so let's see how it happens. So you have this reaction here, so that's methane. Okay, one carbon alkane, that's methane, reacting with chlorine to give you the product here. So how does that happen? So you have the hydrogen here. Okay, so the carbon is bonded to 4 hydrogen. Okay, and you have that's going to react with chlorine gas. So there's 2 atoms of chlorine bonded together. It's diatomic. So what's going to happen? The chlorine is going to take the place of the hydrogen, and the hydrogen is going to move on the side of the chlorine. So pretty simple. So you have the free hydrogen over there. So you see, so it's taking the place of the hydrogen. So I had to edit that. Be careful, you don't need to show these arrows. Actually, these arrows, they use arrows in a reaction like this are used to show something very specific. So at your level, don't show any arrows. I'm just showing that for the sake of the explanation, to show that the chlorine is going to take the place of the hydrogen, and the hydrogen will take the place of the chlorine. Okay, so this is what happens. So the chlorine was here, so it's now in the position of the hydrogen, and the hydrogen was here, and it's now in the position of the chlorine. So that's what has happened. So it's a substitution reaction. I'm removing the arrows because usually it's used to show something very specific that we're not using it for. So yeah, so that's a substitution reaction, and this has to occur in the presence of UV light. So I'm going to write UV on the arrow to show that UV light is being used. So reagents, we have methane gas, methane, and chlorine gas. And the condition for this reaction is UV light, or you could write bright light or just light. And the product here is, so that's methane with one chlorine atom. So this is called chloromethane. Chloromethane. Now, you can replace any hydrogen, not necessarily just this hydrogen that's going. You could replace any hydrogen by one chlorine, that's fine. So that's chloromethane, there is one chlorine, and this is called, that's not hydrochloric acid, by the way. It says gas here, so it's called hydrogen chloride. Hydrogen chloride gas. So that's the products. Now, let's see more substitution, how more substitution could take place. So that's the methane molecule, which has formula CH4. Now, if you replace one hydrogen by a chlorine atom, so in this case we're replacing this hydrogen here by chlorine atom, so one hydrogen is gone, so you end up with chloromethane, which is going to have formula CH3Cl. So chloromethane. In chloromethane, if this is going to react with more chlorine gas in the presence of UV light, this is going to give you dichloromethane, which means that the Cl is going to replace another hydrogen. So this hydrogen is gone here. So you see this hydrogen is gone here. So now you have a chlorine in its place. So now it's dichloromethane. So it has substituted two hydrogen. So CH2Cl2, that's dichloromethane. Trichloromethane, so you're going to react dichloromethane with more chlorine gas, UV light. So free hydrogen is going to be replaced, so you have CHCl3, trichloromethane. And if you react with more chlorine gas in UV light, you have tetrachloromethane, which is CCl4. Now, just note, chloromethane, dichloromethane, di means 2, trichloromethane, tri means 3, tetrachloromethane, tetra means 4. So you can see the substitution taking place here. Okay, so that's what's going to happen. So if more hydrogen atoms need to be replaced, you can react it with more chlorine. So chloromethane can react with more chlorine to form dichloromethane and hydrogen chloride gas. So you can write an equation. So chloromethane is CH3Cl. React with more chlorine in the presence of UV light is going to give you dichloromethane plus hydrogen chloride gas. Okay, so you can see this. And you're going to show this reaction using displayed formula just like that. So for this reaction, you're going to show it just like that. And you're going to do that in your copybook. Take a picture and then upload it in the document. Okay. So then dichloromethane react with chlorine, you'll have trichloromethane. And trichloromethane can react with chlorine. I'll let you guess the two products. Write the chemical equation, show with full displayed formula. Example 2 is reaction of ethane now. Now we're going to look at ethane, C2H6, reacting with chlorine gas in the presence of UV light. I let you write down the equation and show the reaction using full displayed formula. So this is going to be the end of alkanes, and you're going to answer all the questions in the document. Okay?